Welcome to the third video for the tactics movement tutorial. In the last video we finished up calculating our adjacency list for tiles that the player can move to from its current tile. In this video we're going to cover the breadth first search algorithm to determine selectable tiles that the player can legally move to for their current move speed. So the player move script, which defines the movement for the player, actually derives from the tactics move script. The tactics move script is what we're going to be using for holding all of the movement algorithms, both the BFS, the A star for the NPC movement, as well as the moving from tiles and jumping up and down from tiles. It's all going to be stored here in tactics move because it's going to be shared between the players and NPCs. So we're going to need some information here. For example, we're going to need the move ability of the player. We're going to default that to 5. That means they can move 5 tiles per turn. We're also going to need their jump height. And I'm making this a float. And the reason is that it probably would be an integer, but we can actually have them do half steps as well. And I'm going to default to a jump height of 2, meaning they can jump up 2 tiles high or they can drop down 2 tiles. Some other things we're going to need is the velocity vector. The velocity is going to be how fast the player moves from tile to tile. And then we're also going to need a heading vector, which is the direction that the player or the character is heading in. The other thing that we need is a list of tiles, and these are the selectable tiles. And the reason we need a list of these is that we need to be able to basically reset those tiles once the player moves. The player only shows these tiles when it's their turn, and when they're moving or when it's not their turn, those tiles need to return back to their normal color, which is the white color that we used back into the tile for the default when there's no flag set. So we need this to set us back to that point. Another variable we're going to need is an array of all the game objects, all the tiles, but as game objects. And we're going to actually grab those in a init. So tiles equals new, actually tiles equals game object dot find, find game objects with tag tile. This is going to basically cache all the tiles into a single array that we can use to access them, particularly when we're calculating the adjacency matrix, the adjacency lists. We need to be able to access those tiles. Now, if your game has tiles that appear and disappear, and not just become unwalkable, but actually are added or removed, then you would need to be doing this every frame, every time you're doing an update and calculating the algorithm. However, since mine is a static map, meaning I'm not going to allow the tiles to disappear or reappear. They can move, but they just can't disappear or be added. So I'm going to cache all of that right away. We also need to define the move speed. 2 is a good value, but we can adjust it. This is how fast the unit will walk across the tiles. Another variable we're going to need is actually the path. The path is going to be a stack because the path is going to be calculated in reverse order. I mentioned in the previous video that when we move from tile to tile, we actually start at the end of the selection and then we follow the parent back to the beginning. that gives us the path in reverse order. So by using a stack, we're able to push them on in reverse order and then pull them off as we're going. We also want to be able to track the current tile. This is the tile that the character is currently, well, is actually starting on initially. And we'll calculate that at the beginning of every turn. Another variable that I want to store, I call the half height. The reason we need the half height is that I want to be able to cache how tall the tile is, at least half the tile. Because the height, well, where the player sits, or the unit sits on top of a tile, is actually halfway. The center point is the half, the middle of the unit. So half height gives us the distance from the tile to the center of the player, and that way we can calculate where the players will be standing on top of a tile. Since this is a function that we're going to be, or a variable we're going to be using a lot, and there is some tricky math to get to it, and I just want to be able to calculate that just up front. It's not, unless the height of your player changes from frame to frame, if there's a grow or a shrink, then you'd have to recalculate it every time. But since our players, our characters are not going to be changing size, we don't really need to worry about it. So to get the half height, we actually need to get it from the collider. The collider contains the collision box, which in this case is well, let's actually go look at it. The collision box for the player is a capsule collider, and the height is 2, therefore the half height would be 1, but actually it's multiplied by the scale, so the half height will actually be 0.9 once we do it. So this is the value that we're going to cache. So we get the collider, and from there we get the bounds and then the extents in the y-axis, and that gives us the half height. So now that we've defined the majority of the variables we need and we've calculated the tiles and the half height, we need to create some helper functions. One of the more important ones we're going to need is the ability to get the current tile. This is the current tile sitting underneath this unit, whether it's a player or an NPC. And we're going to need to find the tile under, because this is going to be our starting point for pathfinding. Now, we're going to be using this in multiple places. We also need to have a way of getting a target tile. And that was actually going to take a game object called target. And the purpose of the target tile is that we want to be able to pick a tile somewhere out there, for example, the tile that another unit is sitting on top of. So for the current tile, the target will actually be, in fact, let's just use the function real quick. Current tile will equal get target tile of the game object. That's going to get the target tile for this unit. We also may need to use the target tile to find enemy units. If, for example, the A star requires an endpoint, so the NPC will look for the player and it'll actually want to know how to get to the tile that that player is sitting on. So in order to do that, we need to use a raycast again. And so we need a raycast hit variable. If physics.raycast target transform position. We're going to be looking downwards, so it's negative vector 3 up. I'll put the hit, and we only need to go down 1. Because our tile widths or heights are 1 anyway, it will never go through a tile. So that will actually locate the tile, and then we just return, or we can actually save it here. Let's save tile equal to null. Return tile. In this case, though, we found the tile. So tile equals hit.collider get component tile. On the off chance there's no tile there, it'll return null. But we should never be in a situation where we have a player or unit that is not sitting on top of a tile. That's just the nature of tactics. You're always sitting on a tile of some sort. So this will get a tile to a target. So again, in our current tile, we're going to get the target of the current game object. And then once we have that current tile, we can set the current value of the tile. Remember, the tile has a variable called current, and it'll actually turn it magenta pink color for us. So that way we've identified what the current tile is. So we're going to be needing that. That's going to be pretty important. Another helper function we need is we have to compute the adjacency lists. We've already written the code for computing the adjacency list for each of the individual tiles. So now it's just a matter of going through each tile. So for each game object tile in tiles, then we just need to grab the tile script from the game object. So t equals tile dot get component tile. We know every single one of those game objects is a tile because we grabbed tile tags earlier. T dot find neighbors, and then we pass in the jump height for the current unit. This will find all the walkable tiles for this particular unit. Now, I mentioned earlier that if you do have a map that changes size, i.e. you add and delete tiles, you'll want to move this into here. I'm going to comment that out because I don't want to do that. But you could move that into there, and it would find all the currently active tiles, those tiles that are in the scene, and it would catch new and deleted tiles. So that would be a pretty important thing to have if your map changes. And now most tactics games, the map doesn't change like that, but that's not to say that your game doesn't have that capability. Okay, so now that we can put in the breadth first search, which we are going to call find selectable tiles. Now the first thing that we do is we have to call the compute adjacency list function. The next thing we do is we get the current tile. So we compute the adjacency list for this unit, we get the current tile that we're sitting on, and now we're ready to start BFS. Now BFS uses a queue, in this case a queue of tiles, for processing. So we're just going to create a queue real quick. Now we've already set up the tile to support BFS. So we have the visited, flag, the parent, and then the distance. And then we're going to incorporate that. So the first step in BFS is we have to add the current tile. So process enqueue current tile. So we can also set the current tile visited flag to true. And the reason is that we never want to come back to this current tile. Once it's processed, we never come back to visit it. Technically, we could also set the parent, but what will we set the parent as? In this case, we're going to leave the parent as null so that we can find it when we're backtracking to get our path. In some cases, you would actually put the parent would be to itself. But in this case, I want to leave it as null because we do not actually want to include the current tile in the path. So we want to stop processing the path when we get to the current tile. Now we need a while loop, and essentially while the queue is not empty, we will continue processing. Essentially, what would happen is if the queue ever did get empty, then we would have no legal moves. So sometime in the future, we would probably have to address what would happen if there's nothing to process. Now, because we're using BFS to find selectable tiles, we're not actually using it for pathfinding, this really isn't a concern of ours. If it doesn't find any tiles beyond the first one, then that just means the player can't move. So I'm not too concerned about this ending early. So from here on out, we're just going to process each tile that's essentially at the head of the queue. So tile T equals process.dq. That will pop off the front and essentially allow us to now process this one tile. So the first thing that we do is that we actually add this tile to the selectable tile list. The next thing we want to do is we want to set the selectable flag to true. What that'll do is that'll go to the tile and set the selectable flag, and that will actually turn them red. So all the selectable tiles will then turn red. Now that we've actually processed the tile, we have to add all of its neighbors, its adjacent tiles, to the queue. So tile in T dot adjacency list. Now, we do not process visited tiles. If we've already processed a tile, we do not process it a second time. We only process a tile once. So now it's time to process this tile that we're now finding. And we want to set the parent of this tile equal to the tile that we were originally processing. So we grab this tile, we set it selectable, we look through its adjacent. So anything adjacent to it will now go back and set that original tile as the parent. We set visited to true, so we never come back to process this tile. It's only processed once. And the last thing we do is we set the distance equal to 1 plus the distance of the parent. So what the distances allows us to do is it allows us to continuously add 1 every time we look at tiles in an ever increasing arc away from the start tile. The last thing we want to do with this adjacent tile is we want to add it to the queue by calling process.enqueue. This will add it to the queue so that this tile can later be processed. So this is the BFS algorithm, and it does basically it starts with one tile and then grows outward for all the neighboring tiles and the neighboring tiles of that tile. Now the one thing that we need to do specific to the tactics game is that we need to keep in track of how far we've moved, and we have this distance variable which keeps track how far away from the start tile we are. In order to use that though, we need to check the distance, so t.distance. If it's less than move, meaning we haven't hit the edge yet, then we can look at the neighbors. But if the distance becomes equal or greater than move, and it should never become greater, the worst it should become equal to move, then it can't go on any further, meaning we'd stop processing. So we really do want this to process all the nodes within the moved space, meaning the distance, which is less than move, and then stop. So this while loop will process only those nodes that are less than move. And again, we start at 0 with the start node, and we add 1 to it every time there's a new parent. And eventually what will happen is we'll start hitting all of these, we'll pull everything out of the queue, and there won't be anything left. The while loop ends, the function ends, and then we have set all of those selectable tiles to true. And we'll be able to see that on the screen. So now that we have the find selectable tiles function, we need to put it to use. So what we're going to do is go back to player move, and in update we can put in find selectable tiles, and it'll just go through and find those tiles. Go back to Unity and we play it. It has all the tiles that that player can reach. Now 1, 2, 3, 4, 5. So you can see it can move 5 in any direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It can go 5 in any direction. So those are the selectable tiles. So in order to be able to select those tiles, we now have to add mouse click functionality so that we can select each tile that we want the player to move to. So I want to add something first to the tactics move script, and it's another flag, public bool moving, and we want to set it to false. And the reason is that the way the tactics game works is that we only look for the selectable tiles when it's not moving. We're actually going to add a move function in here that's going to actually move the unit forward based on the player selection. So first thing we do is we find the selectable tiles. Now we have to be able to check the mouse click. And when the player actually clicks the mouse, and so I'm going to make a check mouse function. So void check mouse. I want to know if they clicked on a selected tile, a selectable tile. If they have, then we can actually move to that tile. Otherwise, we'll ignore it. So we need to essentially process a mouse click. So input dot get mouse button, and I'm actually only going to allow a click once, so I'm going to do get mouse button up, and it's going to be the 0, so it's a left click. And from here I need to create an array, which is camera.main dot screen point to array from input dot mouse position, and that's going to create an array coming in from the screen point array from where the mouse was clicked, and this will turn it into a 3D array that's going to go into our scene. And then we can use physics raycast, so we need a raycast hit, and if physics raycast, pass in the ray, and then out the hit. And if they click off the map, we don't really worry about it. But if they click on the map, then we want to know what did they just click. And we can quickly check that if hit.collider.tag. And for now, I only care if they've clicked on tiles. You can add other functionalities, like if they click on another player, if they click on an enemy, you can show stats or something. Or you can do an immediate attack without movement. But for now, I just want to be able to click on tiles. So what tile did they click on? Well, tile T equals hit.collider.getComponent tile. That'll get the tile script. If T.selectable, we just found the move target. This is going to be the target we're going to move to. So for now, we can say T.target equals true. And that'll turn it green. And we can also do some more code like turning off the moving. In fact, let's go ahead and do that. So once they've clicked on it, moving equals false, meaning you can't move. After you select your destination, you can't move. There's going to be some more stuff we have to do here, but for now, that's the basics of being able to select and click on a tile. So let's go ahead and run this. Find selectable tiles, click on one. Unfortunately, it's turning green, but because I have find selectable tiles constantly happening right there, it's overriding the green. And that's because it should have been moving equals true, not false. Moving equals true. So now if we play it, we get our selectable tiles. Click on one. And then once we get the player move code in place, it'll actually find the path by walking through from the parent to that tile. So let's go and create the path. So in tactics move, I need a new function. Public void move to tile, and then we'll pass it the tile that we're going to move to. I'm also going to take these two assignments, stick them in here, and instead I'm going to call move to tile and then pass in T. So that's the last step here. And once I do that, move to tile will take over, and it's going to basically complete the path. So make sure we clear any existing path. So if there's a path from a previous run, we want to make sure we clear it. So we don't want a path there. Now we want to create the path by essentially we start with what's called the next. We put this to the tile. Now this is the target tile, so this is our end location. We're going to start with the next tile, and we're going to loop until next is null. When next is null, we will reach the start tile. How do we reach the start tile? Is every time through, we set next to the parent. And essentially what will happen is next equals the parent, and so that we're always walking from the parent. So we start on our target, and then we go to the parent of that one, and then we go to the parent of that one. Now the last thing we need to do is, before we assign the parent, is that we need to add, in this case push, the tile onto the path. So once all of the tiles, starting at the end tile and going to essentially when next equals null, we've reached the parent, or not the parent, the start tile. Once we've done that, the stack will have the entire path in reverse order, so that then we can actually walk through it. So in the next video, we're going to cover move. How do we move a tile? How do we move a unit from one tile to another? It's a pretty complicated topic once we get into the ability to jump. So there's a little bit of work we have to do there. But we'll be able to use that for both PCs and NPCs. So I'll see you in the next video.